everybody, welcome to another episode of Isabel Explains, and today we're going to be talking about the difference between vertical asymptotes, horizontal asymptotes, and holes in a graph and how to identify them. Alright, so let's start with a vertical asymptote. The vertical asymptote has one simple rule. It's very easy to find it, and all you have to think about is, when is my denominator 0? Alright, so let's look at the first example. In this example, we have something as simple as x plus 6 over x minus 2. In this case, the denominator being x minus 2, all we're going to do is simply make x minus 2 equal to 0. Alright, so if x minus 2 equals to 0, then x equals 2. And there you go, bam, that's my first vertical asymptote. Now let's look at a second example. When would the denominator be 0? It's like, well, all we have to do is factor it, okay? So in this case, we have x squared minus 3x minus 10, and all we're going to do is equal that to 0. So we're going to do x squared minus 3x minus 10 equals 0, and now we're going to factor it. So how do we factor it? Well, very simple. One of my students actually taught me this. Little X method. I've never used that before. But basically you put the negative 10 at the top, you put the negative 3 at the bottom, and you're going to be looking for the two factors of negative 10 that when you add them, they'll give you negative 3. So what two factors would that be? Well, that would be negative 5 and 2. Because negative 5 times 2 is negative 10, and negative 5 plus 2 is negative 3. So we're just going to rewrite that as x minus 5 times x plus 2, and that is going to be equal to 0. Well, fundamentally, if we think about this, we have a multiplication here that has to equal to 0. Well, that means that one of the two factors have to be 0, right? So either x minus 5 has to be 0 or x plus 2 has to be equal to 0. So in this case, we're actually going to have two vertical asymptotes, and when x minus 5 equals 0, x equals 5, that's my first asymptote, and then when x plus 2 equals 0, then I have that x equals negative 2. Alright, now let's look at how do we find the horizontal asymptote. Well, this one is a little bit trickier, okay? So in this one, we actually have to compare the degrees of the numerator versus the denominator, and based on how they compare to each other, that's how we're going to determine what is the horizontal asymptote of that rational function. So in this case, the first one, we know that the numerator, the degree is going to be 1, because this is the same thing as x to the first power plus 7, and the degree of the denominator is going to be 2, because this is the highest exponent in the denominator. So we have then that the numerator, the degree of the numerator is actually going to be less than the degree of the denominator. Okay? So what does that mean? Anytime you have this combination where the numerator is less than the denominator, the asymptote is simply going to be y equals to 0. It's that simple. The asymptote is going to be the x-axis, so the y is going to be equal to 0. Alright, what about the second example? So we have 3x squared minus 1 over 2x squared minus 4. Well, let's check out the degrees again. That's the first thing you always do. So let's check out the degree of the first one. So we have 3x squared minus 1, the degree is 2 at the top, and 2x squared minus 4, the degree is also 2 at the bottom. That means that the degree of the numerator is the same or equal to the degree of the denominator. So what do I do in that case? Well, all I have to do is actually look for the leading coefficient of the numerator, and you divide it by the leading coefficient of the denominator. It's that simple. So in this case, it's going to be y equals 3 over 2. Bam, done. Alright? And then the last one, last but not least, this is the easiest one, and it's probably going to be your favorite. When you have the degree of the numerator being greater than the degree of the denominator, in this case you have x squared, right? It's degree 2. This one is degree 1, which means that the numerator is greater than the denominator. you do not have a horizontal asymptote. That's it. It's that simple. There you go. There's no horizontal asymptote. Now, you will most likely have an oblique asymptote, which we're not going to talk about today, but that is that for that. Now, the question remains, well, how do I know that it's a horizontal asymptote and it's not a hole? Well, let's find out. All right. On the first two examples, we saw that to find the vertical asymptote, all we had to do was make the denominator equal to 0, and we agreed that the vertical asymptote for the first example is x equal to 2, when x minus 2 equals to 0. And we agreed that after we factored that the vertical asymptote on this one would be x equals to 5 and x equals to negative 2. Now, how were we so certain that it would be a vertical asymptote and not that it would be a hole in the graph? Very simple. Because the numerator did not share any factors with the denominator. In this case, x plus 6 is totally different from x minus 2, and in this case we have x plus 5 at the top and x minus 5 and x plus 2 at the bottom. Therefore, they did not share a factor, so there are no holes in the graph. Now, what happens if you do? That's when you have a hole in the graph. So let's see this example. We have x squared plus x minus 12 divided by x squared plus 6x plus 8. All we have to do to find whether we have vertical asymptotes and or holes, the first thing that we have to do is factor them. So we see that they both share a factor, and that factor will be x plus 4. Okay, so that means that x plus 4 cannot be used to determine a vertical asymptote. Instead, it will be used to determine a hole in the graph. Okay, so the only vertical asymptote is actually going to be x equals negative 2 based on this other factor. So how do we calculate, or how do we find out what specific coordinate is that hole in the graph? Well, we already know that the x is going to be equal to negative 4, but how do we find the y coordinate of that hole? Well, it's very simple. All we're going to do is substitute that negative 4 into the rest of the factors. So what we're going to do is cancel this out, right? Because there are common factors. So like pretty much any other fraction, you're just going to cancel the common factors. And what we're going to do is we're going to substitute that negative 4 into the remaining factors. So there we have it. So the y coordinate of that hole is actually going to be 3.5. So we're going to find a hole at the coordinate negative 4, 3.5. All right, let's put it all together. So let's do this example, and we're going to find all three things. We're going to find the vertical asymptote, the horizontal asymptote, and the holes. And now, because the vertical asymptote and the holes can be found very similarly, the first thing I'm going to do is find the horizontal asymptote. So, how do we find it? Remember that the first thing we're going to do is we're going to look for the degree of each polynomial. And the degree of the numerator is going to be 2. The degree of the denominator is also going to be 2, because they're both squared. So all we're going to do, if you look back a little bit on the video, we saw that when they have the same degree, all we're going to do is divide the leading coefficients. So in this case, for the horizontal asymptote, my y is going to be equal to 2 over 1. We know that this is an implied 1 there. So this is 2 over 1, which is 2. That's going to be my horizontal asymptote. Now let's find out what are my vertical asymptotes and the holes of the graph. So let's factor. So now we see here that they actually are going to share a factor, and the factor is going to be x plus 1. So x plus 1 is going to have to be eliminated in terms of the vertical asymptote. The x plus 1 does not qualify to give us a vertical asymptote. So the only vertical asymptote we're going to have is going to be x equals 4. Now, what about the hole in the graph? We know we have a hole in the graph because of the x plus 1 being on both the numerator and denominator. So all we're going to do is we're going to substitute negative 1, because it's what it would make the 0 in the denominator. So we're going to substitute x equals negative 1. We're going to substitute it in the rest of the factors. Alright, so the hole is actually going to be in the coordinate -1, -8/5. Hi everybody, that is all for today. Please let me know if you have any other questions or if there's any other topics you would like me to discuss. Email me at isabelexplains@gmail.com, and I'll see you guys next time.